So the first thing we're going to do is very simple. We're going to take these letter names, which are really just the same as the letter names on the piano keyboard. I've just written them out in a more straightforward way. And we're going to replace them with numbers. We're going to do this in two ways in this lecture actually, but this first way and the second way are used in different contexts. This first way is used more by what you might call classical music theorists. The second way is used maybe more by jazz and rock type musicians. We'll look at both because they both have their applications, but we will look at this one first. So here's how it's going to go. Now, you might say, well, it's not really clear how this is going to give me any advantage. Sure, I don't have to have those funny sharps anymore, and of course we would have flats here as well, so this would be C sharp or D flat and so on. But, you know, so it tidies things up maybe a little bit, but it's not really clear that we've gained very much. There is, however, one important thing that this method has that this method does not have. And the important thing is that this 0 could be attached to any pitch class. C is the name of a particular pitch class. If I hit, let's say, if I hit this note on the piano and I say that's a C, I'm wrong, right? I've made a mistake. That pitch class, that sound is called an E. Over here, this 0 I attach to a C just because there it was, right? What I could do is attach it to something else. So I'm going to see if I can just seize hold of all of these. There we go. What I'm going to do is I'm going to say, let's attach that 0 to something else instead. Let's call E the note 0. Okay. Now notice how this lines up just in the way you'd expect. And we go all the way up to 11, which is D sharp, and the next note would be E. Of course, we're still only interested in pitch classes, so the next E will be another 0. 0 refers to the pitch class E. But I can slide this thing around as much as I want. So, let's go back to the 0 matching up with C for the moment. And let's just have a look at how this thing works, get a feel for it. So, let's look at a C major triad. We would use the notes C, right, then E, and then G. If you don't know that, just accept it as a fact. A C major triad has those notes in it. That's a given for us. Well, it seems as if we could write this down. I'm going to use a curly bracket to gather these things together. We could write this down as C is 0, E is 4, and G is 7. So it seems to me that I can write a C major triad excuse me, as 4, 0, 4, 7. Okay, now let's say I want an A major triad. Here's how I do it. I'm going to put the 0 on the note A, which is all the way over here. There it is, A. Right. And I'm going to remember that what I need is 0, 4, 7. So the notes I'm going to choose are 0, 4, and 7. Those are the notes A, C sharp, and E. And if you know anything about the major triads, hopefully you recognize that this really is an A major triad. So it seems like this structure here captures the idea of major triad. And we make the 0, if we want an F sharp major triad, we're going to take this 0, line it up with the F sharp. So this is going to be the root. Okay. Just before I go on, you'll notice I'm talking about this major triad as a major chord, a major triad, and this is a course on scale theory, not a course on chord theory. But in fact it will turn out that this fits our definition of a scale just as well as the pentatonic or the major scale or whatever, it won't matter to us very much that there are only 3 notes here, or that we often play all the notes simultaneously. We don't really care about any of those things. We'll discuss that apparent weirdness, if it does still seem weird to you, in the next lecture. So for now, just go with it and let's agree to call this an object that a scale theorist might be interested in. So let's look at one more example, because a moment ago we were looking at the minor pentatonic, and we were looking at the minor pentatonic in A, the A minor pentatonic. And that had the notes A, C, D, E, and G in it. So let's write those notes down as numbered pitch classes. We have 0, 3, 5, 7, and 10. Okay. And I asked you before, how are we ever going to figure out what a B minor pentatonic looks like? Well, let's line up our 0 with the note B and take a look. We should have the notes 0, 3, 5, 7, and 10. They should be the pitch classes that we have. And those are the notes B, D, E, F sharp, and A. Well, I hope you can hear that that's clearly a B minor pentatonic. So it seems as if this thing here really is minor pentatonic. And by positioning the 0 on the root note, we get what we want. We get the specific minor pentatonic scale that we want, B minor pentatonic, as opposed to A minor pentatonic, which we were playing earlier. Notice the same sound, but shifted. And that shifting is just exactly this shifting that we're doing with these numbers underneath the lettered pitches. Alright, so we could say that the pitch class defines scale, or rather this thing, which is the pitch, this thing, which is the pitch class set. Those of you with any maths background will understand now why I'm using these curly brackets around it. They're usually used for set notation. This thing really is just a set. So we can go with that. We can say that's our definition. I'd like to show you one other possible definition that is related to this one. So, and it's about intervals. We haven't really talked about intervals yet. For our purposes, an interval is just the number of steps between any two of these. So what I'm going to do is I'm actually just going to copy this thing. Okay, so for our purposes, an interval is just the number of steps between two notes, and we're going to probably mostly, again, not care about octaves. So if we get a whole octave, 12 steps, we'll just take those out. So let's just do an example of this. The interval between D, the interval between D and F sharp is going to be 1, 2, 3, 4 semitones, 4 steps. We'll call the size of this, we'll just call this interval 4, right? We don't really care at this stage that it's a major third or whatever it is. That's just going to cause confusion. We just call it 4. So let's calculate the intervals in the minor pentatonic. Here they are. Our minor pentatonic was 0, 3, 5, 7, 10, and for completeness it's nice to have the last interval, which is the interval between the last note and the next root. In other words, 0, 3, 5, 7, 10, 0. That interval is good to know as well. And we can easily read off, this is one of the good things about these being numbers, we can easily read off the interval because we just take one away from the other until we get to here when it gets a bit more complicated. We get 3 here, 3, 4, 5, that's going to be 2, that's going to be 2, that's going to be 3, whoops, that's going to be 3 steps, and this one we may just have to do with our fingers. We go 10, 11, and then the next one is 0, so that is going to be another 2. So this is what I'm going to call, this is not standard terminology, but I'm going to call it this: 3, 2, 2, 3, 2 is the interval sequence of the minor pentatonic. The interval sequence. And I hope that you can see that the interval sequence exactly determines the pitch class set, as long as we start on 0. If we have a convention that we always start with 0, then we follow the interval sequence, we will always and only get the same pitch class set. If you give me a pitch class set, I will always get one exact interval sequence. So there is a one-to-one exact relationship between these two things. And that means that if I can call this a scale, if I can use this as my definition of a scale, a pitch class set, I can also use interval sequence as a definition of a scale. And sometimes that will be useful. Notice something. I've written this in square brackets. I could have written it in round brackets or something, but I've just written it in square brackets to distinguish it from the pitch class set. If you have a pitch class set, I suppose it doesn't matter what order you write them in. I mean, if you give me 3, 10, 7, 0, 5, that's still a minor pentatonic scale. It's weird looking, and I have to rearrange it to make sense of it and say, oh yeah, there it is. But this cannot be a different scale, because it's just the same notes in a different order. And scale theory will say nothing about what order you should play the notes in your scale. But in this case, the order is very important. If I write down, for example, this interval sequence, it's got the same intervals in it. It's got 2 3s and 3 2s, just like this one has, but it's not going to sound the same at all. Check it out. Let's see. Totally different, right? It's got 5 notes in it. It's got certain properties that we can investigate after we've done the second and third lectures, if we want to. We won't look at this particular scale, I don't think, but you know, you'll be equipped to do that if you're interested in the sound of it. But it certainly is not the same as you can hear the change, right? Completely different scale. So the order matters here on the interval sequence. It does not matter here in the pitch class set. There's one other thing that I want to point out, which I'll write in a kind of formal way. Let me write this in a formal way for the people with a maths head. If you don't have a maths head, you may want to look away now. So the interval sequence I'm going to define as xi. Okay, these are all xi's. This is x1. Well, let's say this is x0, x1, x2, x3, x4. Right. Notice we've got 5 intervals. and 5 pitches. Not surprising, is it? When you see how the interval sequence is constructed just by this method, you're always going to get one interval for each pitch. Let's just clarify that. One interval maps to one pitch, the starting pitch of the interval, right? We don't count this one because it's just a copy of this one, right? Okay. My theorem, which is very simple, you can prove it yourself if you are thus inclined, is that xi is an interval map an interval sequence, is, if and only if the sum over all the xi's is equal to 12. That's a little aside for the people who like a bit of maths. Those of you who are not interested in that, don't understand what I mean, just ignore it. Personally, though, this interval, leaving that aside for a minute, this interval sequence I find a useful way to think about scales. Maybe especially as a guitar player, because the interval sequence is kind of what a fingering on the guitar is. It fixes the gaps between the notes, how far you have to jump to get from one note to the other. It doesn't fix the pitch classes. It doesn't fix C sharp or E flat. It doesn't do that because I can move it around. And if you play an instrument that has similar behavior, then this might appeal to you intuitively more than the pitch class set approach. Realistically, when solving problems about scales, both of these can be useful. They can be useful in different places. So we'll have both of them in our toolbox, and we'll put another representation in our toolbox at the end of this lecture. The first order of business in the next lecture will be to create yet another representation of scales, which will also be useful. The more ways you have of looking at something and representing it, the more useful tricks you have for solving problems.